Dear students and participants of this course on railway engineering, today we are going to talk about wagons and coning of wheels. In the previous lecture, we talked about the loading gauges, construction gauges, maximum moving dimensions, wheels and axles, locomotives and their classifications. In these classifications, we have seen that the locomotives have two types of wheels. One is carrying wheel, another one is driving wheel, and then within the driving wheel it can be an independent wheel or a coupled wheel, and based on that the nomenclature will be there. And that is where we have seen that the nomenclatures finally can come up in terms of the WAP, WAG, or likewise depending on for which particular gauge that is being manufactured, what is the traction, and what is the type of load it is going to carry, whether it is passengers, freight, or the mixed type. Now, as I said, in today's discussion, we are going to concentrate or focus and a typical condition, the coning of wheels, which is being done because of certain reasons, and then how the coning of wheel helps in mitigating those reasons or the problems which have been faced by the railways all over the world. And then finally, what are the remedial measures which have been adopted? And what is the problem with these ICF coaches? Now, today we are aspiring to go to higher speeds. Previously, when these coaches were manufactured, we were talking about a speed of up to only 100 kilometers per hour or 120 kilometers per hour. Now the speeds are approaching 160 kilometers per hour, and we are aspiring to have 200 kilometers per hour or more than 200 kilometers per hour. In the introduction itself, I talked about a high speed rail, and there when we are talking about the Mumbai Ahmedabad high speed rail corridor, the potential there is of 320 kilometers per hour. Now looking at these type of aspects, the ICF coaches were examined and it was found that there is a limitation in terms of the speed potential. At a higher speeds, they will not be providing a comfortable journey. The vibrations will be higher. There is possibility of a more wear and tear of those particular coaches. The another issue which has been faced is a heavy corrosion of the ICF coaches. Now, this heavy corrosion of the ICF coaches is because of the type of material which has been used in the manufacturing of these coaches. So, this is another aspect which the Indian Railways thought of looking at, and what are the potential other materials which can be used or the manufacturing of these coaches is further being looked at, and that is where the LHB coaches have come in. As I said, if you are going at a higher speed, then the riding comfort is not there. Even at the lower speeds also, in terms of like we are talking about 80 or 90, the riding comfort was not there. So, because of this poor riding comfort, it was thought of, let us improve upon the system and have a better system because the user is paying for it. Now, wearing of parts in the under gear system below this particular coach or a wagon or the flatbed above system which is there. So, in this particular area, the wearing of parts again has been observed to be much more, and that is where looking at these aspects, the maintenance and the repair of these coaches became a big problem. It was costly also, and periodical maintenances were required. Now, when we talk about the LHB coaches, as I said, these LHB coaches, they have been designed in Germany by Alstom LHB, and the bogies have been constructed by the Messrs Guyot, SIG, and Switzerland. So, the two systems are there, one is at the top, another is at the bottom. So, one is being done by Alstom, another is being done by Guyot, SIG, and a combination of that has been used as the LHB coaches by us. Now, what are the benefits when we are using these LHB coaches? Of course, we have seen that there are certain demerits in using the ICF coaches. So, those demerits are going to be removed when we go for LHB coaches. So, we talked about corrosion, we talked about the speed potential, we talked about the comfort of the users. So, those things will not be there in these particular coaches because of the design, because of the type of the upholstery which is being used, because of the type of the system or the cushions which have been there, or the sizes which have been provided inside the coaches. So, let us look at that. The very first thing is they are a bit longer than the ICF coaches by around 2 meters, and that improved upon the carrying capacity of the coach. And when we say here the carrying capacity, we are talking about the number of passengers who can be taken in one coach from one location to another location. Of course, this number of passengers are going to be different based on which type of a coach we are talking about or discussing. We are talking about a second tier, or we are talking 3 tier, we are talking AC coaches. Within AC coaches, we are talking third AC or second AC or first AC, or we are talking of chair cars, or within chair cars, second chair car, or a AC chair car, or an executive chair car. All of these things obviously will make a difference in terms of the number of passengers to be carried, but the capacity has increased. Another thing is they have the lower weight but better pay to tear ratio, that is number of passengers being carried by weight, and that increases the efficiency of the system, that increases in terms of the fuel efficiency, that increases in terms of possibility of transporting them at a higher speeds. Another is the low corrosion. The corrosion, if it is low, it is because of the type of the material which is being used, or because of the design which is being incorporated, so that the possibility of those corroding environments, and when they interact with the material here, becomes lesser. So, here the very first thing is that the stainless steel has been used, and that has helped in reducing the corrosion. And when you talk about these things, obviously the another important aspect which will come, not only because of the corrosion, but because of the other materials or the replacements or the wear and tear, it says that the replacement and removal requirements are after 1,000,000 kilometers. So, in the case of LHB coaches, this is a very big advantage, and this advantage has culminated into a low maintenance. So, periodical maintenance has reduced, we are going to do it at a very large duration, and at the same time what is to be replaced is also not many, and that has helped in economizing the maintenance procedure. These are aesthetically better interiors which are being provided in these particular coaches. That's towards the user point of view. The user should feel happy when they are traveling in this type of a coach. Another benefit which has been there is that the fastenings which have been used inside, they are not visible. So, there are no visible screws inside the compartment. Previously, it used to happen if the screw comes out of that particular location, will create a problem to the user. There may be scratches, or there can be a tear of a cloth, etc. But now that problem will not be there. Then better passenger comfort and better riding index. Now, riding index, because the type of the bogie which has been used here provides you lesser vibrations which are being transmitted to the coach above, and the coach is being resting on the bogie. We have discussed about it previously. So, that better riding index is being attained by using LHB coaches. There is a better passenger safety. Why there is a better passenger safety? On 3 accounts. One is the use of free retarding material for furnishing. Another is that even if something happens, the openable emergency windows have been provided in these coaches. And third thing is that there is a vertically interlocked center buffer coupler. That means this is a coupler which is being provided at this point where the 2 coaches are being jointed together. Previously, these couplers were a bit difficult to be placed or taken out, but now this is a vertically interlocked system, and because of that it has become easier. So, if something happens to coach number 1, then this can be very detached with respect to the coach number 2 at the back, or coach number 0 at the front. So, that is another requirement in terms of the safety under the extreme conditions. Now, better passenger amenities have been provided. There is more space for pantry. There is individual reading light, not only in the chair cars, but also they have been provided in the sleeper coaches too. Wherever you are lying down in the night, you need not to disturb others by switching on the other big lights. You just use the light which is being given to you on your sleeper and read the material. So that reading lights have been provided, and the designs have been ergonomically designed, because that means the chairs etc which are there, or the backrests etc which are there, they are such that if you are sitting there for a longer period of time, still you as a user or a passenger will not feel a fatigue. You will not feel that you have traveled such a long time and you are now feeling dizzy or something like that. Another thing is, now let us look at some of the salient features related to the LHV coaches. Now, the coach body is of low corrosive stainless steel. We already talked about it. The another thing is the weight is 10% less as compared to the ICF coaches, and it is less by 10%, and we have so many coaches which have been attached together. So it means if you have 10 coaches, 10 into 10 means there is a one coach extra which can be added to the locomotive having a certain hauling power. So that means now there is a possibility of increasing the overall capacity of the train or the route on which the passengers can be transported. A heat and sound insulation has been provided. So this is one another important aspect. So if you are sitting inside, you may not feel a heat. The train is passing through an area. Now we are approaching the peak season of summer. So the temperatures are going to be 40 degrees centigrade, 45, 50 degrees centigrade, maybe more than that at some locations. So the design is such that you may not feel that heat coming inside. At the same time, because the sound insulation is there, the noise levels are going to be lesser, and it has been checked that that remains limited to 60 decibels. There are sealed window glasses which have been provided, specifically if we talk about all these and AC coaches, etc. And they have three types. One is a fixed type where the 12 such sealed window glasses are there per coach. There are openable emergency windows, and they are 4 per coach, and there are hopper type in the lavatories, which is 1 per lavatory. So these are different type of windows and the glass units which have been provided in these LHV coaches. If we talk about the chair cars, AC chair cars, then the roller blinds which have been provided, they are motorized in nature, but in other cases if it's not AC, they are not motorized, but you can do it up and down very easily, because they have been, the design is such that you can do that comfortably. The luggage racks have been provided in the chair cars, and that luggage rack, the design has been changed. As you can see here, this is the new design, a more better design, pleasing design which has been provided, and this can take a load of 100 kgs per meter length. So this is another better side. Then composite wood flooring panels have been provided. This is again a aesthetic parts, and passenger emergency alarms are provided, 2 in the passenger compartments and 3 in the lavatories. There are 3 lavatories being provided in those higher level AC coaches. So 2 can be the Western and 1 can be the Indian type. So in all of those, the alarms have been provided. If something goes wrong, then you can put it this alarm. The lights which have been provided in the coach, there are different type of lights which have been provided. One is fluorescent tube of 18 watts which lit the whole of the compartment or the cabin where you are sitting. There are incandescent lamps of 10 watts which can be used as a night lamps, and then there are halogen lamps of 10 watts again which can be used as a reading lamp. There is a fade bogie which has been provided and which provides a comfort even at a higher speeds of 160 to 200 kilometers per hour. Now, if you look at the seats in the chair car, they are cushioned seats with 450 mm height from the floor. They are 420 mm wide in the chair car, and in the case of executive car, this is a bit higher, 500 mm wide, Again, the designs are such that the body shapes are being taken care of and comfort of the passenger is being taken care of in terms of a medical side. Two other important aspects which were taken care in the LHB coaches were related to the droppings and the excreta which comes out in the laboratories, and previously it was going to the track, and that was creating problem in terms of a corrosion of the sleepers and the rails. Now we have been provided there is a biodigester tank, and this biodigester tank is being designed by Indian Railways and DRDO of the size of 515 by 766 by 1040 in terms of height, width and length. At the same time, the bio-vacuum toilet systems have been provided in these coaches, and therefore nothing is going out, and it has been preserved there for a particular time period till it reaches the destination, and they have been flushed out at using an appropriate system. Then another important thing which has happened is to provide the information system as well as the entertainment systems in the coaches. That was missing previously, and that has been a part of the airways. So now there is a sort of a competition that for shorter distances also, if you are getting these type of things, the people may shift to Indian Railways rather than to going to air. And along with that, from the safety point of view, CCTVs have been provided. Dampers are provided, 4 primary vertical, 2 secondary vertical, 1 secondary lateral and 2 yaw dampers. That means with respect to the vertical axis, whatever the movements are there, so as to control those movements, these are being provided. So here on the right hand side, you can see this is one of the photograph of the laboratory, how it is being designed and what are the facilities which have been provided. Now here you can see that what are the changes which have occurred. So this is a vinyl wrapping on the top of the body of the coach, and that gives a better feeling and makes you feel that you should travel using these particular trains. They are automatic plug doors. Previously the doors used to get inside like this, but now they are sliding in this form and gets automatically locked also. Now inside the coaches, if we talk about the chair cars, and these are the doors which have been provided, and these are again automatic internal sliding doors. As soon as you reach there, you will find that they are shifting to the side and you can very easily move. So there is no need to touch them. In terms of the roof, the 3-tier roof profile has been used, and that has helped in terms of reducing the heat. It has helped in terms of the waterproofing, etc. And increased headroom is being provided for the people who are going to sit at the top of sleeper. Previously those headrooms were a bit lower, so in this case it is a case of a second AC. Electrically controlled roofs, this is a new addition in the Vista Dome addition in the latest coaches which have been incorporated in the Indian Railways. E-leather seats are being provided. So this is for the chair car. The wider sliding windows are provided. Now these windows, if you talk about the sleeper coaches, previously they used to go up and down. Now we have a sliding type of windows being provided there. You can see here again a new addition, the latest one in terms of the seats, which are rotatable by 180 degree. That means you are looking in this direction, but if your friend is sitting at the back, you can just rotate and then you can talk to each other. Here this is a side berth in the AC 3-tier economy coach. Again the designs have been improved, and the way the person can go up and down on the seats, that is also being again designed in a better manner, considering the comfort of the passenger. Then this is for integrated information system. You can see at the back of every seat this information as well as the entertainment system has been provided. CCTV cameras have been installed. Public address system has also been installed. And then there is a child protection seat which is provided inside the laboratories, and fire detection systems are also being provided in the coaches. So if at any location something wrong happens, then that will be intimated to the authorities in a faster manner. So many things have happened in those LHV coaches which have been used. Now few things related here about the dimensions. Now we are talking about dimensions as well as we are talking about the capacity in terms of the passengers who can be taken. So what we found is in the case of AC first, 24 people can be taken, but if you go to AC 2 tier it can be 52. If you go to AC 3 tier it can be 72. Okay, and more than 100 in the case of AC chair car with the double decker system. Length over body. Now these information in the case of AC first, AC 2 and AC 3, they are constant, but if you come to the AC chair car double decker, then the height of the coach from the rail level is increasing, and that is the way the two decks have been provided within the single coach. The maximum width again, more or less they are 3240 mm, but in the case of double decker it is a bit lower. Number of lavatories, they are different, they are 3, 4, 4 and 4, and door sides are 2, 2, 2 being provided. If we talk about the bit lower categories of the passenger travel, then we have second class, we have 3 tier second class chair car or second class chair car, which is further being defined as LWS CZ. So here again what you can found is that in the first three cases, that these values in terms of length over body, length over CBC and height of coach from the rail level, they are constant across these three categories. But when you come to the fourth one, the height of coach from the rail level, this is a bit increased. And if we talk in terms of the number of passengers, the number of passengers here, they are either 199, 102, 78 or 106. Maximum width in general 3240 mm. This is what we have also discussed in the movable parts also, but for this second chair car LWS CZ, it is again a bit lower. Number of lavatories and door sides, they are 4/2 or 3, and the doors are usually 2. Now let us come to the another issue. Now we have the coaches, we have the locomotives, we have the bogies, all those things we have all finally discussed. Now let us come to some issues when we are talking about the wheels, and these wheels are moving at the top of the rails. Now what type of a shape should be there of a wheel? Now if we talk about a wheel which is being shown on the right hand side, now this wheel is having a flat top surface as well as the flat bottom surface, and there is an axle going this side, so that means this is a inner side and that is a outer side. Now if this type of a wheel is moving at the top of the rail, so if we have a rail here in this form, then what happens? Now suppose because of certain jerk this axle moves laterally, and if it is moves laterally on that straight track, what will happen? That this particular wheel will remain at the top of the rail, and there will be more wear on the top surface, as well as this is a flange of the wheel, and this flange of the wheel is a bit longer as compared to the base of this wheel, and this flange will interact with the side of the rail. That means there is a possibility of higher wear and tear on the surface, top surface, as well as on the side of the rail head, and that is one issue which will come if we are using this type of a design. Another thing is that if you are talking about a curved section, so if this is a curved section, then this is R1 and this is R2, so R2 is greater than R1. Now you have the same size of the wheel, you cannot have the two different sizes of the wheel, one on this side and another on that side. So this is not possible. Okay. Now if you do that, then there will be unbalanced movement. Now when the size of the wheels are same and you are moving in this form and R2 is greater than R1, it means the distance travelled on this outer rail is more as compared to the distance travelled on the inner rail. And then how it is possible? Because the diameter which we are talking here, this diameter, this is constant for both of the wheels. So this unequal movement of the curved rails is not possible, and there will be a problem, and this problem is going to be because of the rigidity of the vehicle base, and you will find that finally there will be again more wearing of the system. Now, looking at these particular things, what was decided that we should have a coning of the wheels. The coning of wheels means instead of a flat system, what we are providing? We are providing a inclined system with the flanges. So, you have a flange here as we talked previously. So, this is a flange, an axle, this is inner side, this is outer side. Now, if this angle is being provided, which can be 1 in n, we will discuss what is the value of n, then how it is going to help out. Now, when this is being done, it helps in terms of the controlling the differential movement of front and rear axles, which are caused due to the rigidity of frame and axle when it is negotiating a curved section. Now, when it is negotiating a curved section, how that is going to be different? Now, if I talk on this side, say this is diameter d1, say on this side this is diameter d2, and if I take in the center, then this is diameter average at the center. That means if my wheel is touching at this point, then it is moving at a average diameter, and if the same thing is happening on the other side also, then the train will be moving on the straight track. Now, the total distance which is being moved on the outer rail as well as the inner rail is going to be same. But suppose my train, this wheel touches like this, that means now the diameter has increased. Now, if the diameter has increased, that means the total distance travelled is also going to be more, and if there is a third case where it goes in this form, that means it is going towards the outer side, the diameter is reducing in this particular form, the distance travelled is going to be lesser. So, this is the philosophy which was there behind coning of these wheels and resting them on the top of the rail. So, it helped in terms of the reducing the wear and tear of the wheel flanges. Now, the wheel flange was not continuously in touch with the side of the rail head, which previously was happening when we were talking about this. Now, as soon as it has come in this contact, this is not going back, and because of that there is a continuous rubbing action, and that continuous rubbing action will cause the wear. And it also helped in the smooth riding, because always the system will aspire to travel on an average diameter on both the wheels. So, it will try to move. So, there is a sliding action which will be happening because of this type of a diameter, and it will try to come to the average system. Now, let us look at here. Now, if you look at the first case, in the first case, here the diameter is high and here the diameter is lesser. Now, if there is a track is there which is having curves, etc., what you found is that this is a type of movement which can be there. Here it is higher value, here it is lower value, here it is lower, here it is higher value. It means some instability is coming, and the system will try to come to a stable condition, and that is where it will finally try to be on an average diameter. So, what it happens is that this coning surface will try to bring back the wheel to the average diameter by slipping, and on the curved track it shifts, because on the curved track when you are talking, there is a centrifugal force P which is acting outwards. That means it will drive the system towards the outer side, and when it drives the system towards the outer side, then this first case is going to be there. When it comes toward the outer side, then the diameter here is higher and diameter here is lower. That means longer distance is going to be travelled here, and shorter distance is going to be travelled on the inner case, and that is what it is talking. It causes an increase in the diameter. This helps in the moving longer distances on outer curve as compared to the inner wheel, for which the diameter reduces, thus making it to be traversed in the shorter distance. So, the same thing has been shown here. If you are on a straight track, what you can see is it is trying to be on the similar diameters. There is, but at the same time the free lateral movement is possible because there is a gap. This gap is there which is being maintained. At the same time, inside also you can understand it in form of a spring action. And on the case of curve, you can see here this is a diameter D2, this is a diameter D1 which is less than diameter D2. So, lateral and longitudinal clearances allow the slide free negotiation of curves, and that is how it has become possible that the problems which have been faced by a flat system of the wheel has been taken away. Now, what is a problem now with the coning of wheels? Now, that is again an issue. Now, when coning of wheels has been done and your rail is being placed in this form, this is a flat footed rail. The name comes from this flat foot. So, what happens is now this movement is in this form. Now, when this movement is like this, it is continuously touching only this area, and when only this area is being touched and when it comes very nearer, then probably this area is also going to be affected. The higher wear will start taking place on the side of the rail head. So, the wear and tear due to slipping action is going to be there, and if we talk about the slip of the wheel and if we go by the geometry, it comes out to 2 pi theta by 360 into g, where theta is the angle made by the rigid wheel base at the center of the curve, and g is the gauge which is being used. If you are talking about broad gauge, it is 1676 mm, which we can take here. On the basis of that information, if we calculate, then for the broad gauge the slip comes out to be 0.029 meters per degree curve. So, if it is a 1 degree curve, it is 0.029 meters, if it is 2 degree curves, it gets multiplied there. And this eccentric loading which is happening on the rails, and there is a hunting action which is happening again and again, the wheels are coming and they are hitting the rail head. Now, there is a problem here, the negotiating of the does not allow the wheels to move beyond a certain distance. So, finally, how to control that, and that is what we are talking here. It says that what we need to do is we need to tilt the rail. We have tilted the wheel flange. So, this is a wheel which is having this type of an angle. The same angle has been given to the rail. Now, how to give it? It means the rail has to be tilted. Instead of putting being straight, it has been placed at an angle, and this is 1/20 which we are using on Indian railways. As soon as we do that, the lateral bending stresses due to eccentric loading and the wear and tear at the inner edge of the rail head or on the thread of the wheel, they gets reduced. But this rail is being supported on a sleeper. Now, if we do this, then there is going to be a gap. So, how to cater to that, and that is where comes the aging of sleepers. Now, what does it aging of sleepers means? We are going to create something here so that the rail can be seated at an angle of or at a slope of 1/20. That means the sleeper either has to be made in this form. So, we provide this type of a surface, or otherwise we have to provide a bearing plate which has a lesser thickness here and higher thickness at this level. So, these are the two ways in which it can be done. So, we just understand that and we will close it. So, when wooden sleepers are used without bearing plates, what will happen that below the rail seat they are going to move inwards at a slope of 1/20. So, what we have to do is we have to provide an aging here. It is also desirable to provide a recess of 3 to 5 mm deep on the aged rail seats to accommodate the rail foot to restrict the lateral thrust being transmitted to the spikes and to protect the sleepers from getting spikes killed. But then when you are talking about these spikes, they are the fastenings for the wooden sleepers. And the case of treated sleepers, add cutting of recesses to provide even and plain bearing to the bearing plates, and augering should be done before the treatment, and no edging is required for point and crossing sleepers. So, you can see that how the sleeper system has been done, the tilting of rail is being done, the coning of wheels has been, and the combination of that has been talked here. So, with this we close this lecture. So, what we have discussed today, we have discussed about the wagons which are in use on Indian railways, we talked about ICF coaches, we talked about LHB coaches, their benefits, and then we have discussed about a specific condition, that is coning of wheels, tilting of rails and edging of sleepers. With this we close this lecture. Thank you.